What is an ECG? An ECG, or electrocardiogram, is an instrument used to monitor the electrical activity of a heartbeat. Measurements are taken examining the flow of electricity from every beat of the heart. Typically, this occurs with an oscillation frequency of 1.3 Hz, which is equivalent to 80 beats per minute. ECG measurements are taken by attaching leads to the skin of a patient. Because of the physical constraints of monitoring the heart through the surface of the skin, the detectable signal is incredibly small, and electrical noise can be relatively large. This means that real-world ECG instruments use amplifiers and filters to condition the signal. Amplifiers. Amplifiers convert energy from a power source to increase the amplitude of an input signal. A common way to rate this magnification is the ratio of voltage measured at the output port to voltage measured at the input port. This ratio is typically referred to as gain. Let's look at 4 types of amplifiers: inverting, non-inverting, differential, and instrumentation. Inverting amplifiers. An inverting amplifier uses a single op-amp, where the non-inverting input is grounded and the inverting input has the input signal. The gain factor is applied and the output signal is inverted from the input. Non-inverting amplifiers. A non-inverting amplifier also uses a single op-amp. In this case, the non-inverting input of the op-amp receives the input signal, while the inverting input is connected to ground. The gain factor is applied and the output is not inverted from the input. Differential amplifiers. A differential amplifier amplifies the difference in voltage between its inputs. This makes this type of circuit a subtractor. Inverting and non-inverting amplifiers are op-amps where one input is connected to ground. A differential amplifier is an op-amp where both input ports receive an input voltage. A gain factor is applied to the difference between the inputs. Instrumentation amplifiers. An instrumentation amplifier combines properties like DC offset, very high input impedance, and high common mode rejection, which is the rejection of unwanted input signal common to both input leads. Often with instrumentation amplifiers, they are constructed so that all the resistors have the same value except for R gain. Then, R gain is adjusted to change the properties of the amplifier. Instrumentation amplifiers have the benefit that they don't draw current from the source being measured. Filters. An electronic filter is a circuit component that allows certain frequencies to transmit and rejects others. They are used in multiple devices such as radios and telephones. Let's look at 4 main types of filters: low pass, high pass, band pass, and band stop. Low pass filter. The low-pass filter allows low-frequency signals to pass through it. Any signal above the filter's cutoff frequency is attenuated. High-pass filter. The high-pass filter is the opposite of the low-pass filter. It allows high-frequency signals to pass through it. Any signal less than the filter's cutoff frequency is attenuated. Band-pass filter. The band-pass filter has a lower and upper threshold. Any frequency that falls between these two values will pass through. Too small and too large frequencies are attenuated. The span of frequencies which can pass through are referred to as the bandwidth. Band stop filter. The band stop filter is the opposite of a band pass filter. It has a lower and an upper threshold. However, the band stop filter attenuates any frequency that falls between these two values. Frequencies below the lower threshold or above the upper threshold can pass through the filter.